Hello, mathematicians. Today we are going to do a problem string. So I really think it's important if you follow along with me and you have something to write with and try out the problems yourself. We will be doing some multiplication. Remember, in a problem string, the first problem helps us to then solve the next problem and we build off of it. So it is like a string of problems, a string of math work that you show on your paper. So our first one that we're going to look at is a simple fact that some of you have been practicing on your quick facts page, a 5 by 3. So if you know the answer, write it down. If not, maybe you skip count by 5s, or maybe you add 5 3 times or skip count by 3 5 times, whatever works for you. We know that these numbers can be flip-flopped. And as you solve it, I am going to just show how I would do a quick array for this, a 5 by 3. And a 5 by 3 is 5, 10, 15. 15. Are you with me there? So 5 groups of 3 is 15. Well, let's try something that should be practiced from last week. What if we had 5 times 10? Go ahead and write the product of 5 times 10 as I do the array, because now it is 5 10 times. And actually, you know what I'm going to do? I'm going to go ahead and build 5 rows of 10. A 5 by 10. 10, 20, 30, 40, 50. Cool. Did you get 50 too? Nice. So 5 times 3 is 15. 5 times 10 is 50. Now, this is where we're going to try something out. What would 5 times 13 be? Well, wait a second. 13 can be broken up into a 10 and 3 ones. A 10 and 3 ones. Watch how I put this together. 5 by 10. I'm going to use a 5 by 10 because that was pretty easy. That was 50. And then I'm going to do 5. It's going to take a little bit longer to make the 5s. A 5 3 times. 1. You know me, I'm very visual, so I want you to be able to see what is happening in this problem too, and not just a square that I draw. Okay, so this array here is showing us 5 groups of 10. And we know that 5 groups of 10, we already solved that in our problem string, that was 50. But we have to multiply 5 by 13, so there's also this group of 5 3s that we have to do. So this is still 5, but now it's a 5 by 3. And we solved 5 by 3 is 15. So when we look at this, we now have 50 and 15 that we have to add together, because all together this is 5 times 13. So we need to put those groups together. 50 and 15 would be 65. So 5 groups of 13 is 65. And again, if you're confused where I got this 13 from, look at this top, how I have a side that is 10 and a side that is 3. 10 and 3 is 13. So again, problem string, we're building off of it. If we know 5 times 3, those basic facts we're practicing on Seesaw, and then we learn a new skill, 5 times 10, now we can put that together to make it easier and not tricky when we see those problems. All right, get it locked in your brain because I'm going to get rid of it all. Goodbye, clear it, and it's not gone. Clear it? Oh, I pressed no. Oopsies, my bad. Okay, and I want to clear all of this too. Okay. Okay, I'm back. I was struggling there to clear my board, but we're still on our problem strings. So this time I'm going to present to you 5 times 20. Some of you already have a trick up your sleeve because you see that 0. But while you are writing this fact and solving it, I'm going to go ahead and model it for us. I'm going to break up that 20 into a 10 and another group of 10. Struggling this morning. Okay, so I'm sure you already have the product written on yours, but I just want to quickly show you that here is my array of my 5 by 20. I have 5 rows of 20, and my 20, I just broke it up into a group of 10 and another 10. So 5 times 10 is 50. This is also 50, and together 5 times 20 is 100. Another way some of you might be doing it, if you know that quick fact, you might take that 5 and that 2 and multiply 5 times 2 is 10, and you do this thing where you add a 0 to the 10 to get 100. I don't know this trick that you're talking about, but it seems to be working. So 5 times 20 is 100. Now, what would happen if our next problem was 5 times 23? You should have a bunch of problems written on your paper to then figure out how we would do this. Pause the video if you need to so that you can really work to solve this. I don't think some of you are pausing it. That's why I'm waiting. What I hope you're noticing is that 23 still has that 20 in it that we just solved. So that 20 is represented here. And it has that 3 extra, which we solved before. So I would take what I already have here, and I would add to it a smaller array of a 5 by 3. And a 5 by 3 is 15. So what I need to do to this 15 is I need to add it to this 5 times 20. So it might look like this. 5 times 20 plus 5 times 3. This is the distributive property. What is it? Distributive property. We have broken up one of the factors to make it easier. Oh, I love zeros. So 5 times 20 is 100, and then we then add that to this other parenthesis thing. 5 times 3 is 15. So 100 plus 15 is 115. Do you see how the distributive property, we break apart the factor to make it much easier to multiply and put together? All right, I want to show you now your next task. Now let's see if we can put it together with a word problem. My neighbor's name is Maggie, and she has 6 chickens. 6 little bok, bok, bok chickens running around her yard all the time. And Charlie and Penny, of course, love them and love to chase them and bark at them. So anyway, she has these 6 chickens. And if each chicken laid a dozen eggs, how many is in a dozen? So each chicken lays a dozen eggs. How many eggs did they lay in all? So there's 6 chickens. Each of them has 12. 6 times 12. Again, watch how I can use tools that are just on my class link. Remember that they're just here for me anytime I need them. Any homework assignment, any task, any problem really, I can come to my class link and these tools are available for me. But anyways, I'm going to use it to solve 6 times 12. So hold on a second. Let's see, 6 groups of 12. There's 12 eggs that one chicken laid. Here's what another chicken laid. Another chicken laid this many eggs. I'm just making 12 quickly because it's a 10 and 2. Wait a second, a 10 and 2. Okay, I like these 10s that are coming out. Okay, let's see. Is that 6 chickens? 1, 2, 3, 4, 5, 6 chickens. Now, when I look at this, it's a clustered mess. What I'm thinking I can do is make those nice arrays like I had on the last screen with our problem string. So I'm thinking that I can make a lovely array of 6 by 10. Do you know where I'm getting that 10 from in the 12? The 1. This one right here. 12 has 110. So I can go 6 times 10, 60. And then I can go 6 times 2. A 6 by 2 array. Moving these 2's is not as easy as it looks. But it's still fun to use a tool. Come on over, eggs. I don't want to break you. Come on, eggs. Here we go. Roop and roop. Wonderful. Okay, so just so that we can see this again, we have 6 rows of 10. I broke up that 12 to get the 10. But I still have or need those 2 extra eggs that each one laid, this. So right here is how I got my 12. The 6 stayed the same because it's just 6 groups of 12. Now to show this distributive property, I broke up that 12. I did 6 times 10, and I'm going to add it to 6 times 2. 6 times 10 is 60, plus 6 times 2, which is 12. 60 plus 12, I should get 72. On Seesaw, you might see this exact same problem, but I want you to model it the way that helps you. You could be making arrays like this. You could be writing this. They mean and show the same thing, but I should see some sort of your thinking, some sort of breakdown of how you are solving these partial products, maybe using the distributive property. I like to see your work, so keep up the hard math work. Bye.